In this lesson, we're going to take a look at maximum and minimum values. So by the end of this lesson, we should be able to find the local and or the absolute maximum and minimum values, also known as the extreme values or the extrema, for a function on some interval, and also be able to find out where those values occur. So what do we mean by absolute maximum and absolute minimum? Or local maximum and local minimum? Well, let's take a look at a function here. Again, we've got some graph of some function f at x, and we've labeled some points here. And for this function, we have restricted the domain of our function. Our domain here is, it's the set of all real numbers such that x is between 8 and 3. Now, if I'm talking about the absolute maximum value of a function, I am talking about what is the largest possible y value that this function can have on the interval that we are looking at. So if we just look at this graph here, what is the largest possible y value that this function can take on? Malcolm. The point is 6, 8, so the value is 8, and where it occurs is at x equals 6. So we can say that this function here has an absolute maximum of 8 at x equals 6. So 8 is the value. The 6 is where it occurs. And when we say that this is the absolute maximum, what we're saying is that the value of the function at 6, so f at 6, is greater than all other values of f at x. Okay. And we should say that this is sort of in our domain. Okay. Well, similarly, we can have an absolute minimum, which is going to be the lowest possible y value that our function takes on, again, in our domain here. So what is the absolute minimum of this function here? Right? 2. And where does it occur? Yeah. Of 2 at x equals 3. And we can say this again. What this is saying is that f at 3 is less than all other f at x in D, in our domain. Okay. Now, this absolute minimum occurs right at what we call one of the endpoints of our domain. So we set our domain to be from x equals 3 to x equals 8. X equals 3 is one of our endpoints, and that's where our absolute minimum occurs. We are going to have, we will have an absolute max, an absolute max and an absolute min anytime our domain is restricted. Some functions have an absolute maximum or an absolute minimum, even when the domain is not restricted. Some functions don't have any absolute maximum or minimum. Okay? But anytime the domain is restricted, you're always going to have an absolute maximum or minimum because you've kind of cut off your function. Okay? Now, let's look at these other points that have been labeled here that are not the endpoints of our function. So we've got 4, 6, we've got 5, 4, and we've got 6, 8. 4, 6 here is not an absolute maximum because it's not the highest possible value that we can have for y on this interval. But that point is greater than any of the points that happen to be right around it in that area of the function. So it's what we call a local maximum. Similarly, this 0.54, well, it isn't the lowest possible value that our function can take on over this domain. It is lower down than all of the points that are right around it. So we call this a local minimum. Similarly, 6, 8, while it's our absolute maximum, we would also consider this a local maximum as well, because again, it is higher than any of the other y values that are sort of right in the sort of the local neighborhood of it. Okay? So a point can be both a local maximum and an absolute maximum. Another name for local max and min, we've talked about them as being turning points up until now. Okay? So we can say, and I've labeled that, let's just say that we have a local max at 4, 6, and another one at 6, 8, and we have a local minimum at that point 5, 4. Now, the final point that I'm going to make here is a point that I think the textbook actually disagrees with me on. Okay? But in my opinion, the endpoints of our domain can be our absolute max and min, or min, okay, like we had for this point at x equals 3, 3, 2. So it can be an absolute max or min, but not a local max or min. Okay? So our absolute maximum or minimum can occur at the endpoints. We're going to say that local maxima or minima do not occur at the endpoints. So even though when we look at this graph, we might say that this point 8, 3, well, it seems to be lower than all of the other points around it, but we really only know how the function behaves on one side of that point. Okay? We don't know what's going on if we were to go to greater points, greater values of x. So for the purposes of this course, we're just going to say, hey, absolute max and min, the endpoints of our domain cannot be absolute maximum or minimum. Okay? So this is all well and good. What should you be able to do? Well, we should be able to find the maximum and minimum values, both the absolute and the local maximum and minimum. And there are always going to be two places where you're going to look for these maximum or minimum values. Number one is you're going to look at the endpoints. The other place to look are what are called the critical numbers. And the critical numbers are points where our derivative is equal to 0, okay, so where it changes from increasing to decreasing, or where our derivative does not exist. So just like we saw in the previous lesson, it's possible that these points where our tangent is horizontal are our local maximum or minimum, or it's also possible that our maximum and minimum occur at our endpoints here. Okay? And your textbook phrases this as Fermat's theorem. Okay? If a function has a local maximum or minimum at x equals c, then we know for sure that the derivative at that point is 0, or the derivative does not exist at that point. So that's sort of their definition of what these critical numbers are. Now keep in mind, just because your derivative is equal to 0 or your derivative doesn't exist doesn't necessarily mean that there is a local maximum or a local minimum there. It just tells you that this is a really good place to look for it if you're trying to find it. Right? So, the kind of question that you're going to see. Find the absolute maximum and minimum points of a function, f at x equals 1/4 x to the power of 4 minus 2x cubed, on the interval -2 to 8. And we've got the square brackets here, so we're including those two endpoints, x equals -2 or x equals -8, in our function. So where do we look for the absolute maximum and minimum? Well, two places. We look at the critical numbers, and then we'll take a look at the endpoints in a little bit. So first, we have to find our critical numbers. Well, our critical numbers occur where our derivative is equal to 0. So what's our derivative here? Well, let's see. 1/4 times 4, so we're going to end up with our derivative is x cubed minus 6x squared. And we want to set that equal to 0. And we solve for the x values. Those x values are going to be our critical numbers. So how do we solve for our x values here? We can factor out x, not just x, but x squared. So factor out our x squared, we get x minus 6 equals 0. So what are our solutions here for a critical number? Ryan, what do you think? What are our solutions here? We got it factored. How do we solve for x now? Remember, what we're going for here are what values of x are going to make either this term 0 or this term 0. So what can I put in this thing in brackets here, Ryan, that is going to make that whole thing in brackets equal to 0? 6, yeah. So x equals 6 is one of our critical numbers. What can I put into this other term out in front that is going to make that other term equal to 0, Ryan? 0. So I've got two solutions here, x equals 0 and x equals 6. So those are our two critical numbers. And if all we want are the absolute maximum and minimum points, what we could really just do here is say we're going to check our critical numbers. We're going to check our endpoints, which are x equals -2 and x equals 8. Sub these x values into the function and figure out from these y values which one is our absolute maximum and which one is our absolute minimum. So we could just evaluate f at 0. Let's do this in order here. Let's do f at -2, f at 0, f at 6, and f at 8. So when x equals -2, our function is equal to 20, f at 0 is 0. F at 6 is negative 108. And f at 8 is 0 again. So just looking at these y values, we know that our absolute maximum has to be 20, because that's the largest y value that we have. At x equals negative 2. And our absolute min has got to be negative 108 at x equals 6. Right? And we know this. We only have to check these 4 points because we know that our absolute max or absolute min can only occur either at the endpoints of our domain or at our critical numbers. Now, this process works fine if you're trying to find the absolute maximum and minimum. It's not as good if you're trying to find local maxima and minima, because it doesn't tell you whether these points, these critical numbers, x equals 0 and x equals 6, which are possible local maxima or minima, I'll just say that, possible local max or min, whether these things are in fact local maxima or local minima. Okay? And in fact, if we look at the graph of this function, it looks something like this. We've got our endpoints here and here. Our critical numbers were x equals 0 and x equals 6. So at x equals 6, we do have a local minimum, but at x equals 0, which was a critical number, we don't have a maximum or a minimum. We've got something weird going on there. So if you want to find local maxima and minima, we need a slightly different test than just evaluating the function at the critical numbers and the endpoints and looking at the numbers. Okay? And that's where our next lesson, the first derivative test, comes in, because it puts all of this stuff that we've talked about in terms of intervals and checking the slope of the tangent together to find maxima or minima.